Hi, and welcome to CyberUp's presentation of the OWASP Top 10. OWASP stands for Open Web Application Security Project. And the top 10 are the top 10 types of viruses, malware, or bugs that your computer can get, or breaches or attacks that a hacker could undertake to mess with your computer or your device or your system or your network. So the first one is SQL injection. When you have a website where you can log in using your name and password, so username John and password 1234, the application checks these credentials with a database. So it's going to check your username against the list of usernames that are approved and authorized, and it's going to check your password against not only your username, but against the approved passwords list in their directory as well. So if there is a username John and a password 1234, then you will be logged in. If not, you will not be logged in. So when you're doing a SQL injection, you're usually using the username of admin or administrator, and then you're typing in some sort of code into the password. In this case, the code is 2 sets of quotation marks or 1 equals 1 in quotation marks. So that means give me all the users where the name administrator has an empty password or where 1 equals 1. 1 equals 1 is always true, so you will be logged in as the administrator. So this is a SQL injection. You basically inputted code into the username or password area of the login, and that allowed you to do a SQL injection and get into the system. The next one is called cross-site scripting, XSS. So this is an example. Here's a cat blog, which has a guest book where you can post messages. So when you're filling out the message form, you type your name, you type your cat, and then you can see underneath the input section on the website, it would show up about story about my cat, and it would say, John says, I have a cat just like that. If the guest book is poorly secured, it is possible to store other things in messages. For example, you might be able to store JavaScript. Because other people can read the guest book, it is possible to abuse the cat blog to help you spread your JavaScript to other readers of the blog. So in this case, what's happening is when you're on that cat blog site, if you are adding a comment or you're clicking on something, you can be redirected to another site, or you can be presented with a pop-up containing a virus download link. Either way, this is a way to cross-site script. So basically what's happening is you're trying to go to the cat weblog website, and the cross-site scripting is either directing you to another site or presenting you with a pop-up that's going to try to get you to click on it that has a virus download link in it. So here you go, name hacker, and then in the comment he put some code. This code allowed the hacker to redirect the website traffic. So when John goes into the cat blog to post, he actually gets redirected to a different website. And getting redirected to a different website can cause all manner of problems. If you're redirected and then you try to log into that website, then your login credentials and your password can be taken by a hacker or by whatever group is attacking that site. Next is broken session management. So each time you visit a website, you get a unique session ID. Through this number, the web server is able to keep track of who you are. So the number has to be kept secret, should be very hard to guess, and may not be changed by other people. Guessing a session ID can be very easy. So in the, again, in the login section, you can type in session ID and my session ID +1. And then you can force other people to share their session. So basically what happens is the credentials of users are combined, and an email example of this type of attack would be the hacker would say, I can't log in, can you try it for me? And he would send a session ID that is his session, that if you try to log into it, then it would allow him or her to combine credentials or to get into the system and do bad things. Insecure direct object reference is number 4. And so as an example, we'll take a website with a change your password form. So here you see the change your password, you've got the username inputted there, and it wants your old password, new password, and then confirm it. If you select view source in your browser, which on the Chrome browser, if you click on the 3 dots in the upper right-hand corner, you can view the source code. The source code is HTML or the CSS script that's been written for that website. So if you change some of that code, then you can possibly reset someone's password. So in this case, they're changing the action of the employee ID. So instead of the employee ID prompting a password, it will prompt you to reset someone else's password. All right, now cross-site request forgery is number 5. So this is very similar to cross-site scripting. So the cat blog example is is a fitting one for this as well. So here you have your guest book. John inputted his comment. You can see it on the cat blog, story about my cat. I have a cat just like that. And if the guest book is poorly secured, it's possible to store other things like JavaScript in the message box. Because other visitors can read the guest book, it is possible to abuse the cat blog to help spread your JavaScript to other readers of the blog. By using AJAX, we can abuse active sessions visitors might have with other services like Gmail to send spam through their account. So this is basically saying that in the message box of resetting your password, there could be JavaScript stored in there that you could utilize in order to get login credentials into that site. In addition, the guest book, since other viewers can read that, you can add your JavaScript to whatever link you have in your guest book, or add your JavaScript to your comment, and that can send them to another website where their personal information can be stolen. And then AJAX is a tool that hackers use to send spam through their account. And this would occur if this was done to your Gmail account. So there you have the hacker name and then the code that is HTML or CSS code or a combination. And that is what's going to allow the hacker to send not spam emails, or quote unquote not spam emails from your email address, even if they are actually spam emails. Okay, so in this situation, the hacker posts on the blog, John visits the blog, Jan sends spam to Ann via Gmail without noticing it. So I think that should say John sends spam to Ann via Gmail without noticing it. And that is because when John visited the blog, the JavaScript that was hidden there allowed the hacker to export John's email credentials and password and get into his email. And then they can use John's Gmail to send anybody any kind of messages, and sometimes John doesn't even know it. Now, number 5 is security misconfiguration. Every system needs periodic updates to ensure the latest versions are installed. You always want to check at least once a month to see if your provider or your web hoster or Microsoft or Gmail or Chrome or any of your systems or your programs have updates, and you want to make sure to download those updates as quickly as possible and run those so that you can protect yourself from any attacks that could be had by not doing those updates. Number 7, insecure cryptographic storage. So this is incorrect secure data. In your database, in plain text, it should never store the username, the email, and the password. All of these things should be encrypted. The username should be encrypted, the email should be encrypted, and the password should be encrypted. And the reason why we want to encrypt these things is that if someone does enter into your database, then you don't want them to have access to the real username, the real email, and the real password of your users. If they have an encrypted version, then they can attempt to unencrypt that. If your hash is strong enough, then it is unlikely that they will be able to unencrypt that information. Number 8 is failure to restrict URL access. So in this one, we modify the URL of a website, and you can do it with any browser. So basically, you are adding something to the end of the web address in order to change it to something that will send them to a site that you're in control of instead of sending them to the site that they want to go to. Now, number 9 is insufficient transport layer protection. So with HTTPS, this is the secure version of HTTP. So this is the new thing that Chrome and all the other browsers are going to. The server and client negotiate about the level of security. Together, they figure out what the highest level of encryption is that they can use for the connection. So problems here, a virus can turn down the encryption level of a browser to the lowest possible setting so that it makes the information on that browser very easily unencrypted. Then badly configured servers agree with the low setting and set up a badly encrypted connection. And then last, the web hacker can eavesdrop on the secure traffic between the server and the client. So because the web address and the server are set at the lowest possible setting and badly configured, then the encryption is bad, and it allows the hacker to basically go man in the middle between you and between your website and intercept all of that traffic. Then if people cannot reach our website, but you can, there's a good possibility that our server won't drop to their suggested encryption level. Browsers give very bad error message when this happens. And here you can see kind of the client handshake is what it's called. It's called a SYN-ACK, or a handshake between the client and the server. So the client says hello, the server says hello. They both exchange their encrypted keys. Then the client unencrypts the key and the server unencrypts the key. The client sends a request to the server to get something, and then the server sends that data to the client that they have requested. And then last, number 10 is unvalidated redirects and forwards, which is also known as a rickroll. So when you open a link to a secure section of a website and you're not logged in, you're often redirected to the login page. After you log in, you get sent back to the original page where you were trying to open. So this is an example of that cat log again. This would be the login page for the admin. Sometimes it is possible to abuse this and send people a link which looks legit and contains a website they trust. However, after they log in, they are sent to somewhere else. So in this case, the hacker has added on to the end of the website address a whole nother website address for YouTube. And the people think that they're just going to the cat blog. However, the hacker is, after they log in, is sending them to a YouTube video. So now we have some solutions to these problems. So in the OWASP top 10, there's a few tools like JBoss, Rails, or Zend that will fix 90% of the problems addressed that we've just gone over. To fix the other 10%, you need to periodically have your application audited by an external party. So this is always a good idea, whether you are doing your financial statements or whether you are using a computer or other technology. It's always a good idea to have your system audited or your documentation audited so that you can make sure that you are up to date and secure as possible. And then make sure you point out the responsibility of the end user. Often the weakest link is an employee who is careless with printed files or leaves his computer logged in. So the end user is always the weakest link in cybersecurity, not just often, but always. So if a computer leaves their computer open, another person or employee can come by and do something to that computer. Or if someone prints off a bunch of files and leaves them on the printer and doesn't go get them, and then someone happens upon those, and those can also be utilized to cause problems for that user as well. All right, and that is it for